Hi, I am Rapid Vignesh. Now I want to explain about HTTP in Wireshark. The Hypertext Transfer Protocol is a fundamental web protocol used for communication between clients and servers on the web. In Wireshark, HTTP traffic can be easily identified and analyzed to understand how browsers request content and how servers respond. A typical HTTP interaction involves a client sending a GET request and a server replying with an HTTP response. Wireshark displays HTTP request methods like GET, POST, and shows status codes such as 200 OK, 104, not found, and more. Steps to capture HTTP GET response in Wireshark. Open Wireshark on your system. Select the correct network interface, example Wi-Fi or Ethernet, depending on your choice. Start the capture by clicking on the shark fin icon. The shark fin icon is shown here. This is the shark fin icon. And to stop the capturing the packets, you need to click on this red icon. Open a web browser and visit any HTTP website. Example HTTP slash some website like google.com. Avoid HTTPS sites since they are encrypted. Stop the capture after the page loads. In the filter bar, enter HTTP and press enter in the filter. Look for an HTTP GET request and a corresponding HTTP 200 OK response. Click on a GET packet to expand HTTP layer in the middle pane. You can see the method requested URI, post, and headers. Click on the response packet to view the return content and headers. This is a screenshot HTTP GET response showing HTTP GET response. Next, coming to NS lookup command in CMD prompt. NS lookup name server lookup is a command line utility used to query domain name system DNS servers. It allows you to obtain the IP address of a domain or the domain name associated with an IP address. This tool is useful for debugging DNS issues and analyzing DNS resolutions. Steps to perform NS lookup. Open the command prompt CMD in Windows. Type the command nslookup space www.mit.edu. Press enter. The output will show DNS server used, reserved IP addresses for the domain. You can also perform reverse lookup using an IP. NS lookup 8.8.8.8. This is a screenshot output for NS lookup command using domain resolution. The second one is IP config command in CMD prompt. The IP config command is used in Windows to display and manage network interface configurations. It shows up IP address, default gateways, subnet masks, and DNS information. Steps to use IP config. Open the command prompt, type the command ipconfig, press enter. You will see the details like shown the IP v4 address, version 4 address, subnet mask, default gateway, DNS servers. To view more detailed info, ipconfig space / all. You need to click this code. This is the output of ipconfig command showing network configuration. Now coming to DNS packet analysis using Wireshark. Introduction to DNS. The domain name system is a hierarchical system and used to translate human readable domain names like www.mit.edu into IP address like this one. When a browser attempts to connect to a website, it must first resolve the domain name through a DNS query. Wireshark enables us to observe this DNS resolution process in detail. DNS queries and responses are usually transmitted using the UDP protocol on port 53. Steps to capture DNS traffic in the Wireshark. Open command prompt and type ipconfig to find your machine IP address. Open Wireshark and apply the display filter. IP address is equals to. Start packet capture by clicking the shark fin icon. Open your browser and visit http www.ietf.org. Stop the capture once the website loads. In the filter bar, type DNS. This will display only DNS query and response packets. Click on DNS query packet to inspect domain requested, query type, and IPs. Now, Click on a DNS response packet to view reserved IPs, TTL, and answer count. This is a figure showing DNS query and response for www.mit.edu captured using Wireshark. UDP packet analysis in Wireshark. Fields in a UDP header. From the selected UDP packet trace in Wireshark, we can observe that the UDP header consists of the following four fields: source port, port of the sender, destination port, port of the receiver, length, total length of the UDP header and data, checksum used for error checking the header and data, length of each UDP header field. From the Wireshark packet details pane, the byte sizes for each of the four fields are: source port 2 bytes, destination port 2 bytes, length 2 bytes, checksum 2 bytes. Total UDP header size 8 bytes. Meaning of the length field. The length field represents the total length of the UDP segment, including both the header and the payload. For example, if the length field shows 28 bytes, the payload is 20 bytes. Number 4. Maximum UDP payload size. The maximum value of the length field is 2 bytes. Subtracting the 8 byte header. Maximum UDP payload is equals to 65527 bytes. Largest possible source port number is equals to 65535. The source port field is 2 bytes long, so the maximum value is 2 power 16 minus 1. Protocol number for UDP. The IP header contains a protocol field that specifies the transport protocol used. For UDP, the protocol number is 17 hexadecimal 0 into 11. This value can be seen in the IP layer of the UDP packet. Port number relationship in request response. By examining a request UDP packet and its corresponding response, the source port of the request becomes the destination port in the response. The destination port of the request becomes the source port in the response. This symmetrically helps map the response to the current application on the sender side. This is the screenshot showing UDP request and response with port reversal shown. Thank you.